Okay, lesson 2.4 talks more about slope. So our objective for this lesson is we're going to find the slopes and equations of parallel and perpendicular lines. We're going to interpret slope as a rate of change, and we're going to find a function's average rate of change. So remember with parallel lines, they're lines that never cross, and they never cross because their rise and their run is exactly the same. So the thing is, with parallel lines, their slopes are equal. They're the same. So it says here, if two non-vertical lines are parallel, then they have the same slope. If two distinct non-vertical lines have the same slope, then they are parallel. And if two distinct vertical lines, both with undefined slopes, then they're parallel. And well, if they both have undefined slopes, that means their slopes are still the same. So the big thing to know about parallel lines, the slopes are the same. So if I know the slope of one line, I know the slope of the line that's parallel to it. All right, so example 1 says write an equation of the line passing through -2, 5 and is parallel to the line whose equation is y equals 3x plus 1. As anytime you see the words parallel or perpendicular and it gives you an equation, that means you're only going to use that equation for its slope. So let's look at that equation. So we got y equals 3x plus 1. Well, as long as it's in y equals mx plus b, slope-intercept form, we can just pull out our slope. Remember, our slope is our m value, which is the number in front of x when it's in this form. Now, once I find that slope, I don't need that equation anymore. So, now we're talking about the line that's parallel. Well, we know parallel lines have slopes that are the same. So that means my new line is going to have a slope that's also 3. And then it also told me that it's going to go through this point here. So it's going through the point -2, 5. Now we just want to write the equation. So if we're going to write the equation, then we're just going to plug this into that point slope form. Remember, we talked about that in 2.3. So y minus y1 equals m times x minus x1. And this is where we only replace the y1, the m, and the x1. Well, we can see our m, and we know an ordered pair is an xy, so it's my x1, y1. So I'm going to set up my skeleton and just put some blanks in here for what I'm going to be plugging in. And then plug them in. What is y1? 5. What is m? 3. What is x1? -2. Now take care of your minus and negatives first. And so notice I have that here, so this becomes x plus 2. Now, if it tells me it wants it in point slope form, this is what we're looking for, okay? You would stop here. If it says slope-intercept form, we're going to keep going. So we're going to distribute the 3. So we get y minus 5 equals 3x plus 6. Move the 5 over, combine it with its like term. And so we get y equals 3x plus 11. Now this is slope-intercept form. And then remember, we talked about one more form. We talked about the general form or the standard form. So I'm going to keep going over here. So we had y equals 3x plus 11. General or standard form has x and y and the constant all on the same side. It's set equal to 0. So the easiest way is going to be to move that y on over, put them in numerical order. So we got 0 equals 3x. I'm sorry, I said numerical, I meant alphabetical. So 3x minus y plus 11. Now, some things to be careful of is you should have no fractions. So remember, if you have fractions, multiply everything by the denominator, and that first value there should be a positive number. So if it was negative, multiply everything by -1. And so this is that general or standard form. All right, then we talk about perpendicular lines. Remember, perpendicular lines are lines that cross at a 90-degree angle. So it says if two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of their slopes, the two lines, is -1, then the two lines are perpendicular. A horizontal line having a slope of 0 is perpendicular to a vertical line having undefined slope. So remember, a horizontal line is going to be perpendicular to a vertical line because they cross at that 90-degree angle, okay? But they said their slopes, the product of their slopes is -1. Well, that's kind of hard to understand. But just remember this, perpendicular lines have slopes that are opposite reciprocals. Now, what does opposite reciprocals mean? Opposite means we're going to change the sign. So if it's positive, it's going to become negative. Negative will become positive. And reciprocal means to flip the fraction. So some examples. Okay, if I have the slope that is, if my slope, well, I'll just do this, is 2/3, then the opposite reciprocal, change the sign, flip the fraction. Okay, if it's -5, remember -5 is the same as -5/1, change the sign, flip the fraction. If it's -1/8, you're going to change the sign and flip your fraction. And 8/1, we go ahead and reduce it to 8. So it'd be a +8. All right, change the sign, flip the fraction, only for perpendicular lines. All right, so example 2 says find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. All right, so notice we're talking about we have an equation and we have the word perpendicular. Remember I said if you have an equation and parallel or equation and perpendicular, you need that equation to find its slope. Well, you can't just say slope is the number in front of the x on this one. It's not in slope-intercept form. So that means you're going to have to get it in slope-intercept form. So let's come over here and let's work this out. So slope-intercept form is just where we solve for y. So there are different ways to do it. Most of y'all move your x and your number over, so I'm going to do that. So we get 3y minus 12 equals -x. Add the 12. And so we get 3y equals -x plus 12. And then we divide everything by 3. And we end up with y equals, now remember in front of that x there was a -1, so this is -1/3x plus, and 12 divided by 3 is a +4. All right, so what is the slope of this line right here? It's the number in front of the x because it's slope-intercept form. Once you're done pulling its slope, you don't need that equation for anything. So now let's talk about the line perpendicular. What do we know about the slopes of lines that are perpendicular? Remember, they're opposite reciprocals. So the slope of my new line, this was a -1/3, so opposite means change the sign. Reciprocal means flip the fraction. Instead of 1/3, it's going to become 3/1. And we can actually reduce that to a +3. Now, this problem only asks for the slope, okay? So our slope is going to be 3. If they had given me an ordered pair, then I would do exactly the same thing that I did in example 1 and write that equation using my point slope form. All right, and then slope, remember slope is just the rate at which the graph is changing, okay? So it says slope is defined as the ratio of the change in y to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. All right, so we're just going to find, what they're saying is, really they're trying to help us label it, okay? So when they ask us, what does a slope represent? It's always whatever the units were of the y per whatever the units are of the x, okay? Because our slope, remember, is the change in y over the change in x. That's why we have y2 minus y1 on top, x2 minus x1 on bottom. So it's going to be the change in y per the change in x, okay? So you're just really going to be looking for those units, okay? You could even say the units in y per the units of x instead of change in, okay? So you just really got to look for those units. Let me put unit up here so we don't forget. Now, you also need to tell, is it increasing or decreasing? You'll be able to tell if your slope is positive. That means something's going up, so it's increasing. And if your slope is negative, right up slope, that means it's decreasing. All right. So example 3, the slope is the rate of change. It says in 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of the linear function representing adult men living alone in the United States. Express the slope correct to 2 decimal places and describe what it represents. All right, so it wants us to find our slope. So in order to find slope, I either need an equation or I need 2 ordered pairs. Well, I don't see any equation in here, but I do see some numbers that make ordered pairs. So in 1990, we know there were 9 million adult men doing whatever. In 2008, there were 14.7 million adult men. Oops. All right, and so we can use this to find our slope using our slope formula. All right, so I'm going to label my ordered pairs. So x1, y1, x2, y2. I'm going to set up my skeleton with my minus signs, and then I'm going to plug in. So y2 is 14.7, y1 is 9, x2 is 2008, and x1 is 1990. All right, I'm going to subtract the top over, subtract the bottom, and then we're going to divide those numbers. So 5.7 divided by 18, I got 0.316 repeated, okay? Now it says correctly to 2 decimal places. So that 6 is going to make that 1 round up. So we're going to have 0.32. Now, so we found the slope. It said, and describe what it represents. Well, what was our y's? Our y's were that 9 and that 14.7. So that is the number of in millions of adult men in the United States living alone. What was our x's? Our x's was the 1990 to 2008. That was our years, okay? So, and my slope is positive. So this represents the increase in, what were our y's? The number of adult men in millions living alone in the U.S. Okay, that was what my y's represented. We're always going to use the word per, and remember my x's were the years, so it's just going to be per year. Okay, there's my slope, and there's what it represents. All right, and then the average rate of change. Remember I just told you rate of change is a slope. So the average rate of change, I'm still just finding a slope. The reason they call it the average rate of change is typically I'm finding the slope from 2 different x values on a graph that is actually not linear. So like I might have this quadratic here. And I might want to know what is the slope of the line that connects these 2 points, okay? Well, there's a linear line that connects them. It's actually called a secant line. All right, so that secant line there is going to have a slope. And so if I know these 2 ordered pairs, then we're looking for that average rate of change, but we're still going to use our slope formula. Difference is, they don't actually tell me the ordered pairs. They're going to give me an equation, and they're going to give me x1, and they're going to give me x2. Well, you're going to have to take x1, plug it into the equation to find y1. You're going to take x2, plug it in that equation to find y2, and then just plug it into your formula. And you can see the formula here. They wrote it a little different, but remember, f of x is the same thing as y, right? So if I put f of x1, that would be y1. And so if I put f of x2, then that would just be my y2. And so you can see here they have f of x2, which that's just the same thing as my y2. F of x1, that's the same thing as my y1. And there's my slope formula, y2 minus y1 over x2 minus x1. Difference is we're going to have to work a little bit more to find our y2 and our y1. They're not going to give it to us. All right, so it says find the average rate of change for f of x equals x cubed from x1 is negative 2 to x2 is 0. All right, it says rate of change. That tells me we're looking for a slope. Notice they gave me x1 and x2. So if I know x1 is negative 2 and x2 is 0, I just got to go through and find y1, and I got to find y2. Well, look at the equation they gave you. So they gave you, in this one, f of x equals x cubed. So first thing I'm going to do, excuse me, the first thing I'm going to do is I'm going to plug in that negative 2 to find its, to find its y value. So if we take the negative 2 and we plug it in, I'm just going to do it below here. Remember, it's x cubed for this problem. So negative 2 cubed is negative 8. And so negative 8 is my y1. Then I'm going to take and plug in x2. So my problem was x cubed. So I'm plugging in 0 for my x. 0 cubed is 0. Now we have our two ordered pairs. We can find the slope between those 2 points. So I'm just going to use my slope formula. Okay, I'm going to set up my skeleton. And then I'm going to plug in. y2 is 0. y1 is at negative 8. x2 is 0. x1 is negative 2. Minus the negatives, remember, are pluses. So I get 8 over 2, which is 4. So we know that our average rate of change is equal to 4.